The purpose of this model was that we wanted to show just how much society tries to influence our minds in ways we wouldn't normally expect. For this reason, we decided to look at the popular Barbie and Ken dolls and prove how unproportional they would be if they were actually real people. Our assumptions were all very simple. The first assumption of this model is that someone's proportions have a direct relation to someone's height. This is why we chose to use height to find the scale factor. We also assumed that comparing the average person's proportions to the doll's real-life measurements would give us the best information. Our variables are quite simple. We gave letters to represent each of the dolls, and the px variable simply stands for the measurement if the doll was scaled up to a real person, with the subscript x telling us the age of the doll. Our first step was taking the average person's height at that age divided by the doll's height to find our scale factor. We then took the scale factor and multiplied it by each doll's measurements. We then compared measurements. Our domain was simply the possible sizes of the doll, and our range was the height of the shortest person to tallest person in the world.
For our represent section, all of our tables for our dolls are color-coded. We did this to help show how proportional each body part would be. The red color represents when the comparison between the average human size and the scaled-up doll size is very different and not at all alike. The orange color represents when the comparison between the two sizes are somewhat different. The green color represents when the comparison between the two are roughly the same, if not exactly the same. And the white box is used to show which value was used to find the scale factor. So if you take a look at Kelly's table, her waist and chest circumference are far different than the average 5-year-old's measurements, so they are in red. Her upper arm circumference, foot length, and wrist measurements are a bit off, so they are in orange. And if you look at her neck, vertical eye measurement, and index finger length, it is not very different, so it's colored green. And if you look at Kelly's height, it is colored white because the value was used to find the scale factor. Now if you take a look at Skipper's table, her knee to hip, waist size, and shoulder to fingertip length are very different than the average 14-year-old. So they are red. Her foot to hip, shoulder to elbow, and elbow to fingertip lengths are a bit off, so they're in orange. And her foot to knee length, hip breadth, and eye length are about the same size as the average 14-year-old, so they're in green. So now, if you look at Barbie's waist, leg length, neck, and head circumference, arm length, and thigh circumference, they are nowhere near proportional, so we put them in red. Her bust and hand length are somewhat close to the average 20-year-old woman, so they are in orange. And her torso and hip circumference are in green because it is very close to the average. And finally, if you take a look at Ken's table, his waist circumference, leg length, neck circumference, and chest circumference are far different than the average 20-year-old male. So they are in red. His arm length, knee to toe length, foot length, and hip circumference are somewhat off from the average, so they are in orange. If you look at his hand length, it is right in line with how large the average 20-year-old man's hands are.
To find out the size of body parts of life-size dolls, we took the scale factor, which we had derived from their height, and multiplied it by a body part measurement of Barbie. For our base measurements, we used the average person's measurements from the CDC and Personal City website. For Kelly, we found the measurements for the average 5-year-old and compared them to our doll's measurements. In the end, we found that the younger Barbies are more proportional compared to the big Barbies, and the waist was the most unproportional. When measuring Skipper, we used the average 14-year-old girl's measurements. Based off of Kelly, we assumed the proportions would not grow too far out of the norm. With this information, we can assume the younger the doll is, the more accurate the measurements will be. When measuring Barbie, we assumed that she would also have proportional measurements in following Kelly and Skipper's pattern. While measuring the dolls, we found that one problem with this method was the measuring. For Ken, we compared the average measurements to the doll and found that Ken's measurements are immensely different than a regular 20-year-old guy. In all, Ken's chest was a lot bigger, and so was his leg length.
Kelly's measurements are all similar to the average 5-year-old girl. Some might be smaller or larger, but they are all around the same size. Some of Skipper's measurements are much smaller than the average 14-year-old girl. Her waist measurement is too small, and her shoulder to fingertip length is also too short. However, most of Skipper's measurements were relatively normal. Barbie is a walking freak show. Barbie's waist is less than half of that of an average woman, making it look like Barbie with an eating disorder or a woman who's been squeezed by a large vice. Also, She has a much bigger bust than the average woman. That would put Pamela Anderson's implants to shame. Her head circumference is almost 3 times that of the average woman, making her resemble the head of Frankenstein. Her legs are so long that she might as well have skyscrapers for legs instead. If Barbie was a real person, she would be a giant, anorexic, giraffe-looking Pamela Anderson with a Frankenstein head. Ken's chest length is over 3 times the size of the average man. The explanation for the strong emphasis on chest could be the society's values of muscular and powerful build in regard to a man appearance. Ken's legs are also too long for the average man. This could make him appear taller, because people in the fashion society think that longer legs are a favorable trait. Ken's hand length is about the same size as the average man. In conclusion, Kelly appears to be the most normal, followed by Skipper. Finally, Ken and Barbie's bodies are blown way out of proportion. It seems that the dolls' figures become more unproportional with the average people as they grow older. We believe that this has to do with growth on expectation to meet a certain body image as people grow.
For our extend section of the model, while everyone else scaled up, we scaled down to find out what an average-sized human would look like if they were a real doll. Our new doll's name is Mildred. To find the measurements of Mildred, we used a scale factor. The scale factor was found by dividing Barbie's height by the average woman's height. With this scale factor, we found the body measurements of an average-sized woman if she were the same size as Barbie. This is what we found. Most of the measurements seemed accurate, except for the neck circumference of Mildred was a lot bigger than Barbie's. Also, Barbie's head circumference is bigger than Mildred's, which would mean if Barbie was a real person, she would be walking around with her head the size of 2 bowling balls.